it's time to introduce one of the most convenient modern C++ features, but also a feature that is sort of tragically misunderstood at first. It's one that people have such high hopes for that it can never live up to them. So it's this. You'll notice that I've got these two variables x and y, and they look sort of as expected. And then I've got this, auto z. And this is a wonderful feature. It turns out I am allowed to do this. We'll try compiling the code to prove it. Sure enough, it compiles. The problem is auto may not do what you expect that it does. It probably can't live up to your expectations. It does something very convenient, but it probably doesn't do what you might want it to. And you should be very careful when you learn a feature like this not to let it get away from you, because if you begin assuming that auto is a solution to all of your typing woes, then you will be very disappointed. So what is the auto keyword? And you'll notice I didn't say what is the auto type. So here are some types. I've got int x, int y. I could make y a float or a double or something. And then I've got auto z. But it turns out that the type of z is not auto. The type of z can't be auto because auto is not a type. Now maybe we'll just write that down. Auto is not a type. Instead, we can think of auto as a keyword, a convenience, where the compiler can do a little bit of work for us because of information that it's already keeping track of. So we notice that x is an int and so is y. And in fact, maybe I should draw out some boxes just to keep track of that myself. So there's x, it's an int. And then there's y, and it's also an int. And y has got the value 10, and x has the value 6. And then I might ask a question like, hey, what's the value of this expression here? So you'll notice that is the initial value of z, is the result of the expression x plus y. So if I ask a question like, what is the value and the type of the expression x plus y? We know that the compiler has to keep track of things like that. So we know that the value of x is 6, the value of y is 10. The type of x is int, and the type of y is also int, which means the type of the result has to be int because int plus int equals int, and the value of the result has to be the number 16. The compiler has to know all of this stuff. If you use an expression like x plus y anywhere, whether it's in a variable initialization or not, the compiler does have to know the types of all the operands and how they interact. The compiler already knows that information. The auto keyword gives you the ability to leverage the compiler's existing knowledge. That's it. So auto is not a type. Auto is a way of having the compiler deduce the type of the variable based on the initial value that you provide. So on line number 12, I'm telling the compiler, please make a variable called z. And as far as the type of z, just give z whatever type makes sense for the expression that I'm assigning as its initial value. And the initial value is x plus y. We just realized that that means that the type of x plus y is int, which means that the type of z is going to be int, and the initial value is going to be 16. I'll run this to prove that point, and sure enough, the initial value of z is 16. So one thing you need to be very careful about is never, ever, ever, ever write auto on top of the variable box for z. Because the type of z is int. The type of z is always going to be int. On line 12, all the compiler did for you when you use the word auto is figure out the initial type of z based on this initial value. Once the type of z is determined, the type of z is permanent. So all the same rules apply as in the C language. So every variable must have a name and a type, and the type of a variable and its name are permanent for the lifetime of the variable. So once the variable is created, you may not change its type. And there is no way around this rule. The auto keyword is not a type. It doesn't give you a way around the rule. Okay, so wait a minute. What's the point then? Well, the point is that we often work in C and C++ with a lot of data where the types of some variables are contingent on the types of others. And an example of that would be where I've got some initial data, like the types of x and y are both int because the values of x and y are set at the beginning of the program. And then as my program runs, I might work with other variables that are constructed based on expressions of x and y. So one example would be, what if I've got, let's see, 10.187. So, I start y off as a float. So if I start y off as a float, and I've written some big long program that already works with x and y, I will expect that the program will now seamlessly adapt. So the initial value of y in this case was now 10.187. And the type of y is now float. When I go to compute the value of z, I would compute the initial value to be, well, x plus y would be 16.187. And the auto keyword says, oh, I pasted in by accident there. The auto keyword says that I should compute the initial type of z based on the initial value. And the initial value was int plus float, and we know that int plus float equals float. The type of z is float. And even if my program weren't just 20 lines, but maybe 1,000 lines, if I change the type of one of my initial variables, anywhere where auto was used, that type would percolate through. I wouldn't have to worry about changing every other use of y to make sure that the proper type was being used by the variable where it's being stored. So we'll try that out. And we can see there that all I did was change the type of y, and the type of z kept pace with that because of the auto keyword. So although the auto keyword doesn't mean that z is some chimera that can change type as needed, it does mean that if the type of the initialization changes, that the type of z will change accordingly. And that's one great reason to use auto. It means when the type of the variable is contingent on what the variable contains when you initialize it, then the type will catch up automatically if the types of the initializer happen to change. But frankly, although that's a good use for auto, and I think underlying, like a use that underlies all of the reasons we use it, that isn't the most obvious reason that auto is so great. Auto is great because when you write code that works with complicated data structures, where you might not know or care that much about the underlying types of anything, you can use auto to work around the need to keep track of all the types of things. So here I have some code that works with two vectors. And I've got a vector of doubles and a vector of ints. And I suppose I could argue that later I might change the element types of the vectors, but even if I don't, and I want to work with elements of either vector, I know that an element of v is going to be a double. But to avoid having to think about that too much, if I ever need to extract an element and store it in a variable, I could just use type auto. Because the compiler knows that v.at0 will be a variable of type double, and therefore make the type of x catch up and just have type double. And so, of course, if I try running this just the way it is, just to verify that the code runs in its initial form, we can then answer these questions that it's asking, which is first, what is the type that I actually end up with for both x and y? And then the second question is, what happens if I modify y later? So I'm not going to fully trace this code. As I mentioned in the previous video, I'm going to post a couple of videos later in the sequence of me tracing through some code involving the auto keyword and some other tracing review, just in case it's been a while since you've done any code tracing. What I am going to do, though, is just sketch out what's happening on lines 14 and 15. So on line 14, I'm creating a new variable called x. There it is. And I'm telling the compiler, first off, set its initial value to v.at0. Okay, so v.at0 would be, we'll index these vectors. Okay, so v.at0 would be 10.6. So x is getting the value 10.6. And then the compiler sees the auto keyword, which says, give x a type that matches the initial value you just assigned. And that initial value was a double, so x is a double. And then do the same thing for y. That's a bit of an oblong box. We'll just... y is going to be initialized to w.at0. That's element 0 of w, there, index w there. It's 6. And w's elements are ints, so y is an int. Okay, great. And then this question here, so I guess we've answered the first question, which is what are the types of x and y? X is a double, y is an int. So notice how the types, I never say auto is the type. No, the auto keyword is a way of having the compiler figure out the type of x for you, but the type of x is still double. That's it. Auto is not a type. The second question, though, is what if I do this? Y equals v.at1. And With the variables drawn out like I've done over here, I think the answer to this question is going to be obvious. But I want to just make sure we drive this home. Just because I used the auto keyword when I created y doesn't mean that the type of y is ever allowed to change. That's the most common misconception that I've noticed. People see the auto keyword and they think, oh, that means the type of y is going to adjust to whatever you put in there. And that is not true. All it means is when y is created, the compiler figures out what type it's supposed to have. But then that type is permanent. Okay, so what is v.at1? So in accordance with the first law of assignment statements, I better figure out this before I work on the answer to that question. Okay, v.at1 would be 1.7. Okay, so I take the value 1.7, which is a double, and I store it in y. But y is an int, so I'm only allowed to store the value just 1. I have to truncate the float to be 1. Notice that the type of y doesn't change so that it can store 1.7. No, this is no different than if I store any other floating point value in an int. I just truncate it and then store it in the int. Y is an int, and so y ends up with the value 1. That's it. Because y's type is int and not auto, there's no chance that the type of y is going to change dynamically or anything. C++ does not support that. You may have learned, if you've learned a language other than C, so for example, the language Python, you might be familiar with cases where the type associated with a variable name can change over time. But that is not going to happen in C++. The same rules apply to typing in C++ as they do in C, which is that once a variable is created, its type is permanent. So we'll try running this just to prove that point. And we'll notice y is 1, because the type of y was int, and that meant that even though what I assigned to it was a double, it can't store a double because it's an int, and so I just store the value 1. And so the key observation to make here is that auto is great because it does give us a way of not having to worry about the exact type of a particular value. But it's not some way of breaking out of the statically typed mindset that we should be in, where a variable has a type and that type is permanent and can't be changed. Unfortunately, that's still the rule, and it's a rule we still have to live with in C++.